Okay, we are asked to graph these functions, and all of these functions have changes. Okay, so first thing, the parent function here is y equal to x squared. So if it was just plain old x squared, it would look like this, right? This is the parent function. Except for it's plus 2 here, and it's not in parentheses, which means it's a vertical shift, and I need to go up 2. So when I sketch my picture, instead of the vertex being at the origin, I'm going to shift it up 2. But other than that, it behaves the same way. And when I draw this graph, typically I write the vertex at the origin, then I go over 1, up 1, and it goes through point 1, 1, and I go left 1, up 1, and it goes through point negative 1, 1. The shape will be the same here, it's just shifted up 2. So I'm still going to go to the right 1 and up 1, and to the left 1 and up 1. So the graph actually looks like this. Alright, let's look at our next one. This is the log function. It says f of x is equal to the log of x minus 2. Because the negative 2 is not in the parentheses, this is also a vertical shift, and I go down 2. Remembering that the log function, we typically only plot one point for the log function, which is 1, 0. Okay? That's what the parent function looks like, but I need to shift it down 2. Okay? So normally it goes through this point, but now I'm going to shift it down 2, so it goes through this point. So instead of going through here, I should go down 2. 1, 2. And then it'll just kind of go like that. It's still going to be asymptotic at the y-axis, but it was just shifted down 2. Alright, this one here looks like the parent function is y equal to x squared, which of course, goes through the origin and looks like that. But this one is going to, because of the x plus 1, it's inside the parentheses, you do the opposite thing. So I'm going to go left 1 unit. So when I resketch my graph, I would say, well, I'm going to go left 1. So normally I go through, the origin. So instead I'm going to just shift that to the left 1. So there's my new vertex. Then I go to the right 1, up 1. Go to the left 1, up 1. So there is the sketch of my transformed function. Let me make sure we can see all of these. Scoot it up a smidge more. Okay. This one here is the log function, but it's going to go right to, I know it's a horizontal shift because the transformation is in the parentheses, the numbers in the parentheses. And I remember that a log function goes through the point 1, 0, and it looks like this, okay? But I'm going to shift it to the right 2 units. The only point that I really plot here is 1, 0. So from that point I'm just going to go 2 units to the right. And normally if you just go 1 unit over, that's where the asymptote is. So really this is going to be kind of like an asymptote here. Okay, you don't really have to dot it in, but I just wanted to illustrate. So the picture is going to look like this. It's going to be asymptotic. Normally it's asymptotic at x equal to 0. Now it's going to be asymptotic at x equal to 2. So that's what the picture looks like. Alright, next we have absolute value function, which normally the parent function just looks like a V with the vertex at the origin. This one, since the minus 3 is outside of the absolute value, it's going to be shifted right 3. Never mind. Let's try that again. It's going to be a vertical shift down 3. If it's not in the parentheses, then it's a vertical shift, and you do exactly what it said. So down 3. So that's what my normal absolute value function looks like. And this time I have to shift it down 3. 1, 2, 3. So it's going to go through there, and then we can sketch the picture of it. Alright, and then we have f of x is equal to negative x cubed. Regular x cubed looks like this, right? Goes through the origin, goes through the point 1, 1, goes through the point negative 1, negative 1. If you make the whole function negative, that is a reflection across the x-axis. So it's kind of like what was here is going to flip down, and what was in the third quadrant is going to flip up to the second quadrant. So it's still going to go through the origin, but instead of going through point 1, 1, it's going to go through point 1, negative 1. And instead of going through negative 1, negative 1, it's going to go through negative 1, positive 1. So the picture, so now it's a decreasing function, and it looks like this.